Hey there, my name is Alfonso and I'm a developer advocate at the Cisco DevNet organization. I'm very happy to be sharing with you one more video from our Hack the RADKit series. This time, we're going to have a look at the second part of our RADKit to Grafana dashboard project. If you haven't seen the previous video, I'm going to leave the link here in the description of this one. But basically, this time, what we're going to do together is have a look at how to launch the entire framework and also how to create our own API endpoints. So without further ado, let's get started. Perfect. We are ready now to spin up our different services and run the whole system for the very first time. But just for you to be aware of what are we actually going to be spinning up, all the different services and containers and whatnot, let's go to the Docker compose.yaml file here in the root part of the directory. I've already talked about all the different components of the system, but let's just have a look at the Docker Compose so we can get into a little bit more of detail. We start with the FastAPI middleware service. This is where we have our FastAPI server, the RADKit SDK up and running, and also where we're going to be having API endpoints, our custom logic, you name it. We have a health check that makes use of a very small Python script, which is going to be constantly polling for the status of the FastAPI server, which will only run when our non-interactive authentication in the RADKit cloud is successful. Once that happens, server comes up, our REST calls are fine, our container is healthy. You can see here that we have just our local network, our image, our ports, just some volume binding for our different configuration files, our security certificates, not much else. Next, we have our Grafana service. This is just for spinning up a Grafana image where we are going to be later creating our dashboard with charts and graphs. And finally, we have the InfluxDB service. This is just this time series database with some ports, some volumes. We have a local network that binds all the components together, and finally some volumes for the database. Now, to spin this Docker Compose and having all the different parts set up nice and fine, we have some makefile targets to build and spin, or we can just use the default one, which is make, which will run all the different processes at once. So we use this target. We are prompted for the private key password that we set up before. I'm just going to put it here now very quickly. And that's it. All our containers, all our services are nice and fine. They are all healthy. How can we actually verify that things are working? For example, for the Grafana container, we have mounted it on the port 3000. So I can just go to my local host, 3000 on my browser, and that's it. The login is going to be available with my default credentials, which are admin. We set that up in the Docker Compose. Now, for my FastAPI middleware, what I can do is that I can send a curl command to one of the API endpoints that is set up by default. Here, I put on the wiki of the repository some very quick hints. So, for example, here I have this curl that is to the endpoint devices, which is going to give me a list of all the devices onboarded in my RADKit inventory. So I will just copy that. I will put it here in my terminal. And that's it. I have my 2 devices. So now we know that all the services are up and running. So it's time to roll our sleeves a little bit and get our hands dirty with some coding. What we are about to do is to set up all the different API endpoints that we need in my FastAPI middleware container, and also to set up, we're going to set up the dashboards in our Grafana container. If you navigate to the folder RADKit to Grafana Fast API middleware, you will find the main.py file. This is the logic of our Fast API container. And just let me walk you through the different functions that come by default in this file in the repository. We have our main function. This one will use our non-interactive authentication to log in with our user to the RADKit cloud, and only when this login is successful, it mounts a Fast API server that we will use for all the REST API endpoints that we have defined above. So if we check the ones that come by default, we have one for the health checks. We have one for giving us all the devices in the RADKit inventory. And then finally, we have one that gives us the interface names of a specific interface. So let's just add our very first custom API endpoints. I have a couple of those here in our repository wiki. Let me get the very first one and just copy it here. This one will get from a specific device. It will execute a specific command, whatever command we want to execute here. It will fetch that device in the inventory, and then it will execute the command, wait for the output, and then give us the raw data. So let me show you how does this looks. I will save it. I will stop here my services, make stop. Good, and then I will trigger them again to regenerate my image to incorporate this new API endpoint. So yes, of course, I am asked for the password once again. That's good. Just wait for these to come up again. Okay, now that it's ready, let's test it out, shall we? I have here a curl command. However, for you to better visualize what's going on, I won't use curl. I'm just going to use this URL. So if I go here to my browser and put it here, yes, I have this information. You see here that I have all the outputs from show IP interface brief. However, bear in mind that all of this is raw data. So imagine that at a Python level, you just want to get specific values like the name of the interface, the status, and the IP address, perhaps. That would be a lot of parsing. That would be a lot of regex, a lot of text FSM, you name it. That's why RADKit SDK comes bundled with a very interesting feature, which is the Jenny parsers. The Jenny parsers are a series of parse files that help us to crunch this data and to transform it into specific data formats for Python that we can later use for getting the information that we need. You can find here more documentation about the Jenny parsers. There's also a list of the supported Jenny parsers based on a platform. I put here the reference in our wiki. You can find it here and here. So now let's go back to our code. And what I want to do is to get this information in a parsed way, a Python dictionary, so I can make more data transformations. I can crunch all this information. So I have here another example. This is going to be the interfaces brief endpoint for my devices. So allow me to copy this and bring it into our main.py file. So I will create here a brand new endpoint. That's it. It's all good. What we're going to do is to use the Jenny parse. We're going to be parsing the show IP interface brief command. We are providing the platform type of this device. RADKit Jenny does best effort for figuring out which is the platform of this device. However, it's a good practice to help it a little bit. So I'm saying, hey, it could be either iOS XR or iOS XE, because these are different kinds of raw outputs. Therefore, that's a different parser for each. Once I get the data, I have here the values. This is a Python dictionary. And the only thing that I'm going to do later on, it's a little bit of data manipulation. Because what I want to have at the end of the day from this API endpoint is a list of different elements, because that's going to make it easier on the Grafana side for the visualization. So I have here the endpoint, it is ready. Let's go back here. Let me clear this out, do my make stop. And then I will regenerate the image. So I provide my password. We wait for the login. We wait for the health checks. And that's it. Now for testing our new endpoint, here I have a curl command. However, I will use my browser once again so that you can see all the different formats that we get in a more pretty way. So let's just go to it. My device P01E, interface is brief. And voila, here we have a really nice, really organized JSON output in which I have for every single interface all the information arranged in a list of dictionaries. So now we can use this data in this format to incorporate our own logic, do all the data checks, all the cross processes that we need for getting intelligence out of this information. The endpoints that we just created in our API, they will give us the configurations only in that specific moment when we call them. However, what if I want to keep track of the changes of a specific parameter in our interfaces over a specific period of time? Let's say, for example, that I want to track the traffic going through my interfaces on a very specific time period and just to see that evolution. So for that, we are going to be using the InfluxDB database. This is specific for time series data. And we will create a brand new endpoint, which will allow us to get that interfaces traffic, all the interfaces from within a specific device. We get that traffic, we save it on a specific bucket within this database with a timestamp, so we can later retrieve it in Grafana and see the evolution on a time period. So let us copy that new endpoint. I have it here in our wiki. This is going to be interfaces traffic. Let me copy it and put it here in our file. And what we are going to do with this one is, yes, we use the show interfaces command. We use our parser for it. We get some information here, our counters, the rate, in rate, and out rate. We add up these values because that's going to be our total traffic within this interface, and then we are going to save it in our InfluxDB database. For that, I have specified here on top some parameters for that database. We have the URL of my InfluxDB service. We have our token for logging in, our organization, and our default bucket, which is going to be my RADKit bucket. So what we're going to do is to create a new point, which is called interface traffic. It will have 2 tags and 1 field. The tags are going to be which device we're talking about, which interface from this device, and then which is the total rate, which is in traffic, out traffic of this specific interface. Once we get that point, we connect to our InfluxDB database and we save that record. So let us have a look at it. Let's see if it works. I will stop once again our services and bring them back again with the new endpoint. Perfect. To test this out, I have here once again a curl command. I will take it. This time I will execute it here in the terminal. So this is my device and then interfaces/traffic. So what is happening right now, once again, my SDK goes to my RADKit service. My RADKit service goes to the device, gets the output of the command. We do the parsing, we get that information, and then we save it as a point in my InfluxDB bucket. You can see here that I got 84 different points, which is for all the interfaces that I have in this device. And if I go to my InfluxDB web UI, which is available, that is in localhost 8086, we should be able to see those records. So let us go there. It's the localhost 8086. We have here our default credentials as specified in the Docker Compose file. So if I go here on the left to buckets, you will see that we have one bucket enabled by default. That's my RADKit bucket. If we go there, you can see that we have interface traffic, total rate. For this device, we have all these different interfaces. There's a pretty quick way to see them here in the web UI. So I can just go here, having our two measurements and our device here. I can go to submit, and then here I can go to simple table. And that's it. Here you can have that information, right? Here it's a 0. However, there will be some interfaces where we actually have some traffic. You can see here, right? Like on Gigabit, Ethernet 1011, we have this traffic. And I can run this endpoint as many times as I want, and I will always get a different timestamp. So then we can track the evolution of this traffic over a period of time. We will later use these records in Grafana to see this evolution in a more clear and more consistent way.